Okay, so like I said, this is percent composition. Percent composition is how we're going to determine it for every element in a compound. Okay? Think of percent as part over whole times 100. So the individual component that we're looking at, the individual element, or the mass, the molar mass contributed by the element, divided by the entire molar mass of the whole compound times 100. So the first step we're going to have to do is write the chemical formula of the substance that we're looking at, of the compound we're looking at. And then calculate the total molar mass and then do the percentages. So we want to calculate, for our first example, we want to calculate the percent composition of each element in sodium fluoride. So we're going to write out the formula for sodium fluoride. Well, when sodium is in a compound, what charge does it have? +1. And when fluorine is in a compound, what charge does it have? -1. So crisscross down, and what do you get as the formula for the whole compound? NaF. Okay. So now we're going to have to calculate the entire molar mass, and then we'll do the percentages. So looking at the periodic table, well, we have one of each, so it's just going to be sodium's mass plus fluorine's mass. What is sodium's mass rounded to 2 decimal places? 22.99. And then plus fluorine's mass rounded to 2 decimal places, which is 19, technically 19.00. So what is our total molar mass? 41.99. And what's our unit? Grams per mole. After we do the percent composition stuff, we'll talk about why we can substitute what a mole is and all that stuff. All right, so that is our total molar mass. That is going to be our denominator in our percent calculations. So we're going to find the percent of sodium and the percent of fluorine. Okay, but that total molar mass is going to be on the bottom, the denominator. The numerator, the top number, is going to be the mass from that individual element. So for sodium, what's going to be our numerator? 22.99. And then for fluorine, our numerator will be 19.00. Okay. So go ahead and do the math there. For percent composition, we're going to keep it to 2 decimal places like we did with our molar masses. And what do you get as the percent of sodium? $54.75. And our unit is going to be percent, and we're going to label that this was the percent of sodium. So from this unit forward, like unit 6 forward, not unit as in percent forward, but from this unit of chemistry forward, we are not only going to provide a unit on our number, but also we're going to label it with what substance we're talking about. So here we're talking about sodium, so we're going to label it Na. All right, and then what's the percent for fluorine? 45.25? I think it rounds up to 2.5. And that's percent fluorine. And those are our 2 answers. We only have 2 answers for this problem because we only have 2 elements in the compound. Now, what do our 2 percentages add up to? They should add up to 100%. Now, some of you might be looking at this and you're like, wait, if I know it's going to add up to 100%, why did I have to do the second calculation? Why did I have to do the 19 over 41.99 times 100? The reason why I still want you to do the individual calculation for each one is because what if when you're finding the percent of sodium, you type something in wrong, and therefore its percentage is now wrong? And then you subtract the wrong percent from 100, and now your percent of fluorine is wrong. And now you get the whole problem wrong because you made a simple error that you could have caught had you done each individual calculation and checked to make sure they add up to 100. Okay? So use the fact that it adds up to 100 as a final check. If it adds up to like 100.01 or like 99.99, that's okay. If it's like 0.1 off, that's fine, because that's going to be from rounding errors. Like, for example, if we had left this as 45.24, if you didn't round it properly, you would have had 99.99. That's okay. Your process was right. But if you add it up and you get like 105 or like 90, something's wrong. It could be you just typed it in wrong. You know, you did 29.99 and then it got all messed up. Okay? All right. This one, same type of thing, just our formula here is going to be more elements. Okay, so we're going to calculate the percent composition of each element in copper 2 sulfate. So we have to first write the formula. Now, your homework worksheet that you picked up on your way in is actually easier than this, because I've already given you the formulas of the individual compounds. And your homework quiz is going to be like your homework. The percent composition quiz in 2 classes is going to be like the homework, where I just give you the formula of a compound and I ask you to find the percent composition of each element. Because I only want to quiz you on finding percent composition. You do still need to know how to write the formulas from the names from Unit 4 for like your tests and stuff. Okay? Just be aware. That stuff's not going away, but your little quiz that you're going to have in a couple classes is just on this new concept. Okay? All right, so let's write the formula for copper 2 sulfate. So copper 2 in copper 2 sulfate has what charge?
2
Plus 2. What's sulfate? SO4 minus 2. So when you crisscross down, what do you get as the, excuse me, as the whole formula? CuSO4. So we have 3 different elements, right? What's our next step?
Calculate the moles.
Calculate the thing, yes. Very specific. Calculate the total molar mass of the whole compound, right? Yeah. So we add up all the numbers from the periodic table. We're going to have to multiply oxygens by 4 because there's 4 of them. Remember, round everything to 2 decimal places. So the total molar mass, what's copper's mass on the periodic table? 63.55. And then we have sulfur, which is 32.06. And we have 4 oxygens. Oxygen is 16.00. Add all those up. And you get a number that you're going to tell me. 159. Grams per mole. 159.61 grams per mole. Okay? So remember, what is that number? That's going to be our denominator in each of our percentages. Okay? So we're going to calculate the percent of copper, the percent of sulfur, and the percent of oxygen. Okay? And again, this 159.61 is our denominator in each of them. What's our numerator for copper? 63.55. Sulfur is 32.06. And then oxygen is what? 64, or 4 times 16, because it's the total mass contributed by that element. And we had 4 oxygens, so we need to account for the 4 oxygens in the percentage as well. Okay? Oh, I didn't mean to say equals. Times 100 equals times 100 equals. All right, how many decimal places are we going to take our percentages to? 2. Round your percentages off to 2 decimal places for each one. Okay? So as you're doing the math, what did you guys get as your percentage for copper? 39.82, and the unit is percent copper. Sulfur? 20.09 percent sulfur. And oxygen? 40.10% oxygen. So those are our 3 answers. We're going to clearly mark our final answers. When you add these up, I think this one adds up to 100.01. And again, that's okay. It just has to do with where we were rounding numbers off to. Okay? Questions on this stuff. Like, this is your homework. Like, this is your quiz, and this is what your homework is. But again, easier because I've already given you the formulas of the compounds. Okay? We're going to go a little bit further with this for right now. The next 2 problems are not on your homework quiz, but you will see it again later in the unit and on your test. But the next little bit, I do want to do these problems now, though. Okay? We ready to move on? All right, so for number 3. Number 3, it says that we are given 5 grams of CuSO4. Hey, that's copper 2 sulfate. That's what we just found the percentages of in number 2. And we want to know what mass of this compound is sulfur. Well, in the last problem, we just calculated what percent was sulfur?
40.10.
Yeah, we just found that in the whole compound, 40.10% is sulfur. Oh, Brendan, you told me wrong. It was 20.09 is sulfur. 40.10 was oxygen. All right, so 20.09% of this whole compound was sulfur. So there's actually 2 ways to do these problems, and we have 2 problems. So I'm going to show you one way, and then I'm going to show you the other way. Yeah, the first way I'm going to do it, set up like a proportion or like a ratio. So we want to know what is the mass of sulfur, so X grams of sulfur in the whole compound. The whole compound is 5 grams. And I just calculated in number 2 that in 100% of the compound we had 20.09% sulfur. So if the units throw you off, if the units and labels throw you off, think of it as this. X over 5 we'll keep sig figs. X over 5 equals 20.09 over 100. How do I solve for X?
And then you divide by 100.
Yeah, you cross multiply and then divide, right? So if we cross multiply, we get X times 100 equals 5 times 20.09. And then you multiply 5 and 20.09 and you divide by 100 to solve for X. Now, this is unlike math in that we do have to account for significant figures. up until this point, percentages and molar masses, we were saying, let's just round them to 2 decimal places. Those are all considered to be constant values. They're never going to change. The mass of sulfur on the periodic table isn't going to change. It's always going to be 32.06. So we're going to look back at the fact that we were told we have a 5.0 gram sample of this compound. That is a measured value. That has a specific number of significant figures that we need to maintain in the problem. How many sig figs does 5.0 grams have? 2. It has 2 sig figs. So we need to have 2 sig figs in our answer. Okay? So if you need to refresh your memory on how to do significant figures, go back to Unit 1 and review that stuff. Okay? What do you get as your answer with 2 sig figs? 1.0. And what's our unit? Grams of what substance? Sulfur. Because of the whole compound, only 1 gram of it is sulfur. Okay? So that, like I said, I have 2 ways to show you this. The first way was through proportions. The second way is mathematically it's the same way, but it's using the percent. It's doing math with the percentage. When you do math with a percentage, do you know what you have to do first? Convert it to a decimal. How do you convert it to a decimal? What? Move it to the right 2, which is the same as dividing by 100, which was one of the steps in our math problem. So, in number 4, we have a different mass of the whole compound, and we want to know what mass is oxygen. And as Brendan told us before, of the whole compound, we had 40.10% oxygen. So instead of setting it up as a proportion, which you can certainly do, if that method makes more sense to you, do it that way. But like I said, I wanted to show you both ways. This, we're going to first divide 40.10% by 100. And that is 0.4010. And then we're going to multiply that by the total mass. 3629 grams. Now, again, sig figs matter here. How many sig figs does 3,629 grams have? How many? 4. Has 4 sig figs, so when we do our math, we need to have 4 sig figs. So what do you get as your mass of oxygen? 1455, or 1,455 grams of oxygen. Okay, so like I said, either way is fine to do it. Just as long as you show your work and you do it correctly. I don't care how you do it. Okay? Questions on that?